Hello everyone, welcome back to the channel. In this video, we will solve a numerical based on stress, strain, and modulus of elasticity for a bolt. The question is, an M10 bolt having a diameter of 10 millimeters is subjected to a tensile force of 15 kilonewtons. The length of the bolt is 50 millimeters, and it elongates by 0.05 millimeters. We are required to calculate the stress in the bolt, the strain in the bolt, and the modulus of elasticity of the material, assuming it is a steel bolt. Let us now solve the problem step by step. Step 1. Cross-sectional area of the bolt. First, we calculate the cross-sectional area of the bolt. The formula for area is A equals pi by 4 dot in to d squared. Substituting the value of diameter as 10 millimeters, the area comes out to be 78.54 square millimeters. Step 2, stress in the bolt. Now, we calculate the stress. Stress is defined as force per unit area. So stress equals 15,000 newtons, as we have to take value in newtons divided by area of 78.54 square millimeters. After calculation, the stress in the bolt is 191 newtons per millimeter square, which is equal to 191 megapascals. Step 3, strain in the bolt. Next, we calculate the strain. Strain is the ratio of change in length to original length, and it has no unit. Here, the change in length is 0.05 millimeters, and the original length is 50 millimeters. So strain equals 0.05 divided by 50, which gives a value of 0.001. Step 4, modulus of elasticity. Finally, we calculate the modulus of elasticity of the bolt material. Modulus of elasticity is defined as stress divided by strain. So 191 divided by 0.001 gives us 191,000 newtons per mm square, or 191 gigapascals.